record it, but let's do the bell work together now, okay? It says, number 1, draw a right triangle with legs that are length 5 centimeters and 9 centimeters. So a right triangle has to have a right angle, okay? A right triangle has to have a right angle. Legs of length 5 centimeters and 9 centimeters. When you make that right angle, the two legs are what make up the sides of that angle. Ty, are you with me? Okay. The hypotenuse is the longest side across from that angle. All right? And what do I need to use? What formula do I need to use when we are finding a missing length of a right triangle? Starts with a P.
E equals MC squared.
No, that's E. It's Pythagorean theorem.
Oh.
So that is A squared plus B squared equals C squared, where A and B are going to be our legs, and C is going to be my hypotenuse, the longest side, okay? So I'm going to say 5 is my A, 5 squared, plus B is going to be 9 squared, equals my hypotenuse squared, but we don't have that, so I'm just going to leave it as C. 5 squared is how much? 25. Plus 9 squared is 81. Equals C squared. 25 plus 81, add those together, which is 106. And that is equal to C squared. Am I looking for C squared?
Yes.
No. I'm looking just for C. So I need to take the square root and take the square root. Anytime you take the square root of something squared, you just get whatever that entity is. In this case, it's just C. And the square root of 106 is 10 point something. Oh. 10.29. Does everybody know how to take the square root?
Yeah.
You hit the second button and you hit the x squared button, which is just to the left of the 7. Now, they want us to take it to the nearest 10th. Which of these digits is in the 10th place? No.
2.
The 2 is in the 10th, and you look next door, it's 5 or more. So is that going to go up or stay the same? Yes. So that is 10.3 centimeters. That is the length of our hypotenuse. What questions do you have about that? Zach. All right. Number 2. Ooh, circles. This is a review from just yesterday, hopefully. If we say this is circle A, what does that tell you that point A is to that circle? What is point A? I'm looking for a name.
Oh.
It's called the... Point A is called the what of the circle?
The center.
The center. Point A is the center, right? So if we want to find the measure of angle A, which is right here, and they tell us that the measure of this arc, and show that. We are very visual. Show that so you can see it in front of you. If the measure of that arc is 102 degrees, What is the measure of this angle?
90. I don't know. 0.
What kind of angle do we call this where it has the vertex at the center?
Semicircle.
No. No, not inscribed.
Oh, the other one.
The center of the circle. So it is a
Minor.
central angle. I try to help you guys as much as I can. So when you have a central angle, the arc that it intercepts is going to be the same amount. So this angle is 102 because it intercepts this arc, which is 102. Okay? Then they want to know what is the measure of angle F. Now, angle F, is that a central angle?
It's 51.
It's what?
51.
It is 51 degrees. This is an inscribed, which you were talking about, Angie. Inscribed angle, and we get it by taking 102 and dividing it by 2, which does give me the 51 degrees. Ty, are you writing some of this down? Probably should. Because guess what? Bell work is going to count again. Guess when I'm going to collect it? Next Wednesday when you have that quest. What questions do you have on 1 or 2 here?
None.
Alex, did you get all this down? Okay. This is a new packet. Did you pick up the new packet, Alexandra? Are you? Oh, okay. You're looking at something else? Okay. All right. So let's turn to page 1 of your notes.
6.1.
Page 1 of your notes. This is 6.1. We're talking about measurements. I think more than measurements, we're talking about areas of quadrilaterals. What the heck is a quadrilateral? Think of the prefix. What does quad mean?
4.
4. So we are talking about quadrilaterals. I would put a big box on it and say that is a 4-sided polygon or figure. A polygon is just a closed.
Circle. So
Is a circle a polygon? That's a good question. Usually polygons have straight sides. So I'm not sure. I think a circle is a circle. I don't think a circle is a polygon. That's a good question, though. I'm going to have to ask one of the other teachers, see if they know.
They would not know.
They might not know.
I know.
All right. Then I want you to put a square around parallelograms. Now, when you usually think of 4-sided figures, go back to your kindergarten days. What are the typical 4-sided figures you're used to?
Boxes.
Squares and...
Cubes.
No, not cubes, not triangles. That's not 4. 4.
A hexagon.
No. Rectangles. Yes, rectangles and squares. Guess what? We're not going to talk about rectangles and squares right now. We're talking about the other lesser known 4-sided polygons, which are parallelograms.
Why are we talking about shapes? What door?
Because we're finding the area of these shapes. So a parallelogram is a quadrilateral. Both pairs of opposite sides are parallel. Both pairs of sides are parallel. Okay? Both pairs of sides are parallel. And that's what these arrows show. Okay? So the two bases here are parallel. That means they do not intersect. They look like a pair of L's. Get it? Parallel, parallels. And they have 2 arrows on the other two sides, and that means those two sides are parallel. Okay? So, here's the important thing. When it comes to talking about, there's a packet in the green tray in the back. You want to finish your test? The important thing you need to know about the area of a parallelogram is that it is base times height. Base times height. Okay? You might put a little cloud around that something so you can find that quickly when you are looking for that formula. And we are going to give you all of these formulas. However, you need to know how to recognize the shape occasionally. Okay? You got a calculator? We give you 15, okay? All right, so here's the important part. If you are going to measure someone's height, everybody look up here because this is important. And it's kind of weird and funny. Are you going to measure their height if it's slanted? No. But guess what? We're going to give you a slant height for a parallelogram, but we don't use that. You need to find the straight up and down height.
But what if they have scoliosis?
You still would measure their height this way.
No.
They would just be bent over. Okay?
Yeah.
But we do not measure zombie slant height. No, we don't measure this. Okay? That's what I want you to remember. We math teachers do weird things to get you to remember stuff. Okay. All right, so let's take a look at this. So I want you to write in here, no, just say no to slant height. Just say no to slant height. Ty, make sure you get that written down. So a parallelogram is just a slanty rectangle. Okay? The base is going to be the whole entire bottom. And the height is going to be perpendicular, meaning it has to form a right angle. So we want the perpendicular height. This is what we want. We do not want slant height. Okay? All right. So let's take a look at this parallelogram at the bottom. Here is my base. Right here. Right there's my base. Okay? My height, again, we want this height that is perpendicular. Well, we don't have it. It's going to be over here. So we're going to have to use Pythagorean theorem to find that height. So we say a squared plus b squared equals c squared. Because we have a right triangle, we see that this bottom leg is 7. We see this leg, b, that's what we don't know because that's the height I want. And we have a hypotenuse, which is slanted. That is 25, which you can't really see because I covered it up. So a is 7 squared plus b, we don't know what this is yet, squared equals c, 25 squared. 7 squared is 49 plus b squared equals 25 times 25, which is 625. Now, I don't want b squared though. Ty, you need to stay awake, okay? Come on. So I need to do what to get b by itself? Subtract 49, yes. So subtract 49 from both sides of the equation. B squared equals, what is it, 576? And I don't want b squared. Don't be squared, just b. Get it? Don't be squared?
No.
Okay. Take the square root. Take the square root. Don't be square. You get it, don't you? And the square root of 576, William, put the phone away. Put the phone so I can see it. No, it's not. There you go. Use your calculator. 24. So 24 is my perpendicular height. And it's 24 feet. Now, this 24 feet is my perpendicular height. I can just move this over here. It's still going to be 24 feet. And now we can find, letter B, the area of this parallelogram, which we know is base times height. The base is the bottom length. Now, only look at your picture. It's not 23 plus 7. It's just 23 times my perpendicular height, which is it 24 or 25? 24. Don't do the slant height, okay? So times 24, and 23 times 24 on your calculators. 550 what? 552. They gave us units, so we have to put feet. And whenever you're finding area, it's going to be squared. So 552 feet squared. Whenever you are finding area, you are trying to find how many little squares make up that figure. What questions do you have on that first example? Base times height, you got to find perpendicular height. Alex, come on. All right, let's go to the next one. I'm going to skip the check for now because I want to get to each of the different types. Our second quadrilateral for today is going to be the trapezoid. A trapezoid. Parallelograms have two pair of parallel sides. A trapezoid has one pair of parallel sides. Okay, and they are called the bases. So we have base 1 and base 2. Kind of like Dr. Seuss's thing 1 and thing 2. We have base 1 and base 2. Base 1, let's just always put 1 at the top so we're consistent, okay? It doesn't matter, but for us, let's just put base 1 at the top. Guess what? We need to find a perpendicular height, and we need to have the perpendicular height. So for a trapezoid, just say no on the slant height. We don't want the slant height. So if they give us a slant height like this, and we need to find the perpendicular height, you're probably going to have to use Pythagorean theorem again. Okay? So may, not always, use Pythagorean theorem. The big formula for the area of a trapezoid, area of a trap, A of a trap, is 1/2 times the height, and that's the perpendicular height again, times the sum of our bases. Put a big cloud around that so you can find that formula quickly. William, put a big cloud around it. Rewrite it and put a big cloud on it. Oh, Miss Edie. So base 1, we're always going to have at the top.
You subtract each.
Base 2 is at the bottom. No, that is times, multiplying.
Times each.
Yes. 1/2 times h times the sum of those bases. So let's go to an example with a trapezoid. This is a trapezoid, and to me, it looks like a cut-off triangle. So area of a trapezoid. Think trapezoid, and it looks like a cut-off triangle. Okay? Is 1/2 times the height times the sum of the bases. Always start with the formula. Okay? Equals 1/2. What? Times the height. Question. This 3 centimeters, is that a slant height or is that a perpendicular height?
It's slants.
Is it slant?
I mean, perpendicular.
Is it perpendicular?
It is going straight.
It is going straight. So yes, there they give it to us as the straight perpendicular height. So we multiply times 3. And then I have to add my bases. Base 1, let's put base 1 at the top. So that's 5 plus base 2 all the way at the bottom, 9. All right, PEMDAS. Am I going to multiply or am I going to do parentheses first?
Multiply.
PEMDAS, P for parentheses. We need to do this first. So 5 plus 9 is 14. I'm going to keep the rest of it the same. And I know we usually tell you go from left to right.
14 times 3.
Well, I'm going to give you a hint here for a second. Usually we multiply from left to right, and you can put the fraction in and say 1/2 times 3 times 14. But when you multiply, you can change the order. If all you're doing is multiplying, you can change the order. So in order for us to do this without using a calculator, although you can, what is half of 14? 7. And then I'm going to take that 7 times the 3, and that's 21 centimeters squared. So you need to remember, a trapezoid looks like a triangle that's cut off. That's how you can tell it's a trapezoid. 1/2 times height times sum of the bases. Again, I'm going to skip the check on this one. And let's go down to our final 2 quadrilaterals of the day.
Only one.
Nope, 2. We're doing 2.
You should do one.
Rhombus and kites.
Kite.
Let's go fly a kite. Now, as you look at these, I want you to think of diamonds. That they both kind of look like diamonds. This is a diamond shape, and the kite kind of looks like a diamond shape also. I mean, they are called rhombus and kite, but I want you to think of diamonds, and I'll tell you why. Before I tell you why, though, it says a rhombus is a parallelogram with 4 sides that are congruent. That's what this means. They are all the same length. So it is a slanty square, basically. It's a square that's been pushed over to the side. Okay? And a kite, this is like an old-timey kite. Old-timey. So the top 2 sides are congruent, and these bottom 2 are congruent. All right? The reason why I want you to think of diamonds when we have a rhombus and a kite is because the formula for the area of them is 1/2 d sub 1, which means it's diagonal, times d sub 2. And that is for both of them, where the d's are the lengths of the diagonals. Okay? So if you see a rhombus and a kite, try to remember they kind of look like diamonds, and you're going to use the d's. Girls, what are we doing back there? I just feel like you're talking, passing. Okay. I'm not upset, but I just feel like you're missing out on kind of what's going on here. Okay. Okay. Nobody's in trouble. I just want to make sure we're focused. Are you done? Okay. Oh, you can keep it there. All right, let's go to the next page. Let's do an example of each. So here's my diamond shape. And it says the diagonals of a rhombus, this is a rhombus, they bisect each other. So this 7 millimeters on the right, millimeters, is also going to be 7 millimeters on the left. And if the top part is 6 millimeters, then it's going to be 6 millimeters on the bottom. So we're going to make diagonal 1 is going to be 7 millimeters plus 7 millimeters, which is equal to 14 millimeters. Diagonal 2, these are the diagonals. They go from one opposite angle to the other opposite angle. Diagonal 2 is 6 millimeters plus 6 millimeters, which is a total of 12 millimeters. So here's my diamond shape. Area is 1/2 times the length of diagonal 1 times the length of diagonal 2. William, phone. So that is 1/2 times diagonal 1 is 14 and diagonal 2 is 12. So do it one at a time. What is half of 14?
7.
7, and 7 times 12 is going to be 84 millimeters squared. Can someone let Blake come back in? That is a rhombus. Shine bright like a diamond. Shine bright like a diamond. So remember that. D's, the D's are in there. You have the pass? Huh? The pass. Just put it on my desk. All right, so let's go to our last example. Where is it? You need to go get it. And you need to be back quickly. All right. Area of a kite. Looks like a diamond. Think diamond. Okay. Think diamond. So area is 1/2 diagonal sub 1 times diagonal sub 2.
So one will be 16.
1 is 16 and 1 is 9. Yep. Can somebody let him back in? So 1/2 times, let's make diagonal 1 be the 9.
Oh,
And let's make 16 the other one for diagonal 2. Thank you. I am going to look for half of my even number. So half of 16 is how much?
3. Oh, 4.
Half, not square root. Half of 16 is 8, right?
I thought you could do 9 first.
Well, the problem with 9 is it's 4.5. It's not an even number. You can take half of an even number easily in your head. So 8 times 9 is 72 inches squared. Now, you can just change or take 1/2 times 9 times 16 on your calculator. So there's nothing wrong with that. Okay? I'm just showing you, if you want to do it a little bit more quickly, how you take half of that number. We are done with the notes for today. So, homework is the front side of 6.1. Where do I find homework 6.1? It's the last page of your packet. Make sure you do the front. There are 6 problems on the front. Blake, put your phone up. Do you have this packet? Do you have the packet? Is that a yes? All right. So we got 5 minutes. You can get started on it.